All right, quadratic key features. How to find your features using the TI Inspire. You're given an equation, x squared plus 6x plus 9, and you're looking to find the vertex, the maximum, the minimum, the x-intercept, the y-intercept, and the axis of symmetry in domain and range. How do you find that? Well, you have to graph your equation. Your first step is to go ahead and look at your equation and begin to analyze it based off of the equation alone. So look at your a value, the number in front of your x squared term. For example, with our exemplar, our a value is negative 1. There's a 1 there that you cannot see, negative 1. So that means that our graph would open down this way, which means it would have a maximum. So make sure you're sketching your graphs on each of these questions. The a value, the number in front of the x squared term, or coefficient of our x squared term, is 1. There's a 1 that you cannot see, so our a value is 1. It's a positive 1. Positive meaning smiley face. Smiley face. Smiley face opening up, which means it would have a minimum. We use circle minimum. So let's go ahead and graph our equation. Click your on button, click enter, click new, number 1, new, no, enter, click add graphs, number 2, and go ahead and put your function in. So x squared plus 6x plus 6x, make sure you're putting it in correctly, plus 6x plus 9, plus 9. Make sure you're careful that a negative x squared is a negative, the small negative. Minus 1 is our minus key. Okay, x squared plus 6x plus 9, enter, and there's your graph. Go ahead and zoom in. So your next step is zoom fit, Click on menu, click on zoom, number 4 is zoom, 4 for zoom. A, zoom fit, A, zoom fit, so you can see it bigger. Make sure you trace this graph. That way you remember what it looked like, and it looks something like this. Okay, make sure you're tracing it on your paper. Let's go ahead and find our key features. Hit menu and hit trace, number 5. Trace, number 5. Graph trace, number 1. There's your spider. Take your spider and crawl around your parabola, this quadratic function, this blue curve. Take your spider and crawl until you find some key features. You go right or left. Well, there's one. It shows you our y-intercept is 0, 9. So there's one of our key features, 0, 9, 0, 9. Go to the left, keep going. It will tell you our next feature. Keep going. We've got a 0. Our 0 is negative 3, 0. Our x-intercept, negative 3, 0. Negative 3, 0. X-intercept, negative 3, 0. I think this only has 1 0 possibly. Let's keep going to the left and see if there's another 0. There might be another one. I think there's not. So we found a couple of our key features. This one's not giving us all of our key features, so we can analyze the graph and find some more. So go ahead and click on menu, and then analyze graph. Number 6. You can find all your features this way. Analyze graph. We're looking for our minimum, our vertex. minimum. So go ahead and click on minimum. Number 2. It's asking for our lower bound. So scroll, take this dashed line and scroll. Let's go ahead and find our lower limit and hit enter. Now it's asking for upper bound. So scroll to our upper limit. Just scroll, and hit enter. So make sure your region is shaded. It's telling you your minimum or your vertex is -3, 0. Our vertex is -3, 0, which means our minimum value, which is y, our y value is 0. That means our axis of symmetry, which is x equals, if you draw a line down the middle, split this u in half, this parabola, what x value are you at? -3. Our x value is -3. So our axis of symmetry is x equals -3. There is no maximum. Our domain, how far to the left does this curve stretch? Well, you can't see it, but you can assume all real numbers to the left and to the right, it stretches infinitely. So infinitely, your infinite sign, all real numbers, a double R. You might see it in these forms, all real numbers. And we'll add that the domain are the x values. So that curve stretched from the left infinitely all the way to the right infinitely. So this curve, this parabola, this function starts -infinity and it goes to the right +infinity. So your domain is your horizontal stretch. How far does it go to the left and how far does it go to the right? And so we would say x is greater than -infinity, but it's less than +infinity. It sounds crazy, but the x values of our function sit between these two numbers, infinity. So this curve stretches along these x values forever. All real numbers. Your x values of this function are all real numbers. So that's what domain means. Now for the range, our range is the opposite. So our range is what is our lowest y value and our highest y value on this curve. Where does this curve start and where does it end? Well, our curve starts at 0. It doesn't go below 0. It's starting at 0, and it's going above 0. And it will go forever. If you keep going up, you'll see it doesn't stop. You can at least assume that. You can actually prove that, but we're not going into all that. But you don't see that it's stopping necessarily. So our range starts at 0, and it goes above. So our range is our y values of this curve start at 0 and go above or equal to 0. So that's our range. And as you can see, your range is the same thing as your minimum. It starts at 0. It's the bottom of this curve is at 0. The bottom is at 0 and above. Okay, our y values start at 0 and it goes above. Starts at 0, that's the bottom, and this curve goes above 0. Yeah, if it makes it easier, you can label this one x and y. -3 is our x. Axis of symmetry is x equals something. Where is the axis of symmetry? Where does it cross through the middle? At -3. -3. Do you see that? Those match. Our minimum is going through 0. That's the bottom of our curve. Y at 0. Y equals 0.